There's 5 numbers. I want to divide them evenly, fairly, into 2 groups. I've done it by writing 12 plus 22 plus 31, and that's equal to 17 plus 48. Notice there's 3 numbers on one side and 2 numbers on the other. I don't care about that. What I care about is that the sum is fair. Is it clear? Oh, here's a few more numbers below. Suppose I locked the doors. I won't do this, but suppose I did. And said, you can't get out until you can tell me whether or not it's possible to make a fair division among the numbers at the bottom. Would you eat lunch? Now, once again, in this debate about whether it can be done or cannot be done, one of the 2 sides is in a better position. Because if you're lucky and you figure out how to do it, or maybe you're just very, very smart. One of the 2. And you figure out that it can be done, you say, aha! The answer is yes. And here is the way to divide the numbers. You put 1 stack over here and 1 stack over there. Now, what's the task that the referees have to do? They have to confirm that every number is listed exactly once on one of the 2 sides. All those numbers are different. And how long will that take? A minute? Even by hand. You print the page and you just go off and check them off one by one. And you add up the 2 to make sure that the sum is. How long does it take to add up half those numbers? Another minute? Okay. 1 minute for each. No. Short answer, no. But suppose you're not so lucky, and this really doesn't have anything to do with how smart you are. And you try, and you try, and you're not successful. And after some time, you grow frustrated. And you say, I can't do it. And now I start yelling at you. You're lazy. You're just not paying attention. If you would work harder, you would get this. How do you defend yourself? How do you defend yourself? Now, I bet before lunch, we could settle this. Maybe if we all worked together and came up with some clever scheme for divvying up the labor. But now let's work a slightly harder problem. Suppose I have a 1.44 megabyte floppy disk full of integers. Could we settle the fair division problem for that many integers? Now, when I made up these slides, I said some of you probably don't even know what a floppy disk is. This is show and tell time. They look like this. And they're called floppy because they bend a little bit, but not much. And this is 1.44 megabytes. We used to pay money for these. You used to put entire operating systems. When I first started installing Linux, I used 6 of these. If you did modern installation, you'd need a tray full of them. 1.4 megabytes, not 3.7 gigabytes like in the Windows 10 installation disk. And you can do your math, how many of these would it take? Okay, but you can put a lot of data on one of these. You can put a lot of integers. You can put a pretty big text file. So just imagine a text file. A text file, like not even a Word document, just an ordinary text file with no formatting, in which I put an integer on every line. I can put a lot of integers on this. You got any chance of solving that? As we shall see. You have no chance. Not only do you not have a chance, we don't have a chance. Not only do we don't have a chance, all humankind working together in concert and using all of the computing power, diverting it from particle physics and the search for extraterrestrials and just working on this problem. We're not going to solve it together. It's too hard. It's too hard.